So here we have one of our two lectures for Unit 5 of solving equations, the first of which is solving some equation dealing with basics. So first things first, what is an equation? Well, an equation is when we set two algebraic expressions equal to one another. And when we do that, we call that, well, spoiler, right? We call that an algebraic and not algebraic expression, and now it turns into an algebraic equation. So for example, given two expressions, one of our expressions right there, 3x minus 5, another expression right here, 10 plus 2x, when we set these two equal to one another, we now have an equation. So when we do this, we're going to be employing the use of that equal sign in the middle. So where before with expressions we didn't have any equal signs, or we couldn't really solve for something, now with equations we can finally do that. So whenever we perform any action on either side of the equal sign, so any of our four operations, we must do it on one side. That then tells us we must do it on both sides of the equal sign. So that equal sign kind of becomes that balancing act for us. For example, we're going to do two things to this following equation. We're first going to add 4 to both sides, and then we're going to multiply by 2. And we're going to start by doing all that on the left. So first on the left, we're going to add 4. So if I add 4 on this side, it no longer becomes the same thing. So we have 2x, the negative 5 plus a 4. Those were our like terms, just like from expressions. So that's minus 1. Now, this doesn't equal 4x anymore because we need to do it also onto the other side. So we need to make sure that carries over onto the other side. Now, adding and subtracting are typically the easier things when it comes to solving equations. It's multiplying and dividing that can be a little bit tougher. So the next thing we want to do at this point is we just want to multiply the left by 2, but that means multiplying everything by 2. So again, from expressions, we have some distribution that'll take place. But if we do it on that side, we have to do it also on the right side. So again, now, just like in that first step, we had combining like terms, we see we have some distribution happening on either side. So 2 times 2x, that's 4x. 2 times negative 1 is negative 2. And then this 2 gets distributed over here, so we have 8x plus 8. Now this line right here has the same equivalence, same truth behind it as our initial step, because of everything we did on one side, we did on the other. So now when it comes to solving equations, what really is our goal of solving equations? Well, our goal is to isolate or solve for the stated variable. So in cases like above, there's only one variable, right? Just the x. So we want to isolate or solve for that x. And how do we do that? Well, we do that through the use of opposite operations. So we have our 4 operations: addition, subtraction, multiplication, division, and we have some opposites. So let's look into first dealing with some addition and subtraction. So whenever we see any positive numbers or numbers being added, we want to use its opposite operation, which is that of subtraction. So if I see addition, I see something positive, I want to subtract, and vice versa. If I see something negative or I see subtraction, I'm going to add. So if I see subtraction or a negative, I want to do its opposite, which is to add. So we got 2 examples right here. For this first one, we see x on the left, no x on the right. And this x is having a 10 added to it, which means I want to subtract. So to get rid of this 10, I want to subtract, right? Because 10 minus 10 is 0. That leaves just the x on the left-hand side. But remember what we did above. If I do something on the left or on the right, I have to do it on the other side, right? I have to do everything on both sides. So I need to also subtract 10 from the right as well. Well, 17 minus 10, that one's not too bad. We get 7. So if I see addition or I see that positive 10, I want to subtract. And then on the contrary, right, if I see subtraction or I see a negative, you could see it as a negative, we just want to do the opposite of addition. And we want to make sure we do it on both sides. The side we move it from, those are going to cancel each other out, right? Negative 4 and 4 is 0, leaving just the x. And then we have that 9 plus 4, which is 13. So in both of these cases, big thing to remember is opposite operation, and then doing that operation on both sides of the equal sign. And I know sometimes in the past we may have seen it where we draw a line down showing that kind of bar of equality. Feel free to do that as well here. So when we add or subtract with equations, we do so to kind of get these numbers to cancel out, right? We want that positive 10 to cancel with the negative 10. And what we do is we call those additive inverses. Just some terminology for when we get into Algebra 1. And the big thing about algebra inverses, it's just the opposite of whatever we're dealing with, right? If I see a negative 4, I want to bring in that's opposite, which is positive 4. If I see positive 10, bring in the opposite of negative 10. So for an example, if I see some random number, call it a, I just want to always bring in its additive inverse of its opposite or negative a. Well, that covers addition, subtraction. It's not too bad. If we see addition, subtract, see subtraction, we add. Now, whenever we see something being multiplied, I'm sure you can guess by now, we want to use division. And then again, if we see multiplication, we want to use division, or if we see division, we want to use multiplication. So again, we have addition and subtraction going hand in hand, and then we have multiplication and division, something going hand in hand. As we pull onto that second page, we start off at the top with some examples of multiplication and division with solving equations. So for the first, we have 4 times x equals 20, and then we have x divided by 7 is 9. Now, of course, we can do that guess and check method, which at times, something like this one might be easy, but as we get going with equations, we're going to find that method doesn't really work. So how do we do it? Well, opposite operations. If I see multiplication here, I want to divide. So I'm going to make note that I'll be dividing. And then for the second equation, if I see division happening with that variable, then that tells me I want to multiply both sides by something. Well, for the first over here, we want to divide away the number being multiplied by our variable. So if I'm multiplying by 4, I want to divide by 4 on both sides. Reason being, these 4s on the left, those are going to cancel out for us, leaving just the x. And then 20 divided by 4, we know that's just 5. Equally, for the second part of the example, if I'm seeing division of my variable by a number, that number being 7, I want to multiply by that number on both sides. Here again, we'll get canceling happening on the left. That 7 over 7 cancels out, leaving just the x. And then on the right, we have 9 times 7. That's easy enough. That just gives us 63. So again, whichever operation we see, we're using that opposite. And just like with addition, well, we had additive inverses. What we're doing here with the multiplication division is we're finding multiplicative inverses. Again, some fancy notation for Algebra 1. It's just letting us know what can we introduce to get things to cancel out with multiplication and division. Well, if I give you some number a, How do I get things to cancel with multiplication division? Well, I want them to turn into a 1, right? Because 1 times or divided by anything, we get that number back. So if I give you an A, that 1 divided by A is its inverse. And we saw that right up here, right? If I gave you a 4, that 1 divided by 4, just dividing by 4 on both sides, is that inverse. So those are the 4 basic operations when it comes to solving equations. But there's a few other little details that we kind of need to stick to, be consistent with. That way we're all following those same methods. And the first of which is, how do we show our answer? So it's pretty standard form coming for us. When we show our final answer for solving equations, that we have the variable on the left, so the variable comes first, and then we set it equal to whatever its value is on the right of the equal sign. So, for example, looking at this problem, I see addition to my variable by a positive number, so I want to subtract. So I'm doing the opposite of that positive 3. My 3's over here cancel. Nice. 9 minus 3 is 6. But this isn't the form we want to leave it in. So we want to make sure that we use this reflective property where we can reflect everything on both sides of that equal sign and still have a true value. So every time we want to have this in standard form. So variable on the left, the value is equal to on the right. Now, it's not enough always to go on good faith that maybe we didn't make a mistake. The nice thing about solving equations, instead of having even a teacher or a calculator check your work, we can check our answers ourselves to find out if we were right or not using the method of substitution. So as we might see, we're seeing a bunch of our stuff from expressions coming in with equations. So we saw combining like terms already, distribution, and now we're seeing some substitution. So let's see how this works. Substitution. First, let's solve an equation. 7 times w equals 35, and we're going to solve for w. Well, I see multiplication, so I want to use division. If I'm multiplying by 7, I want to divide that away onto the other side. Those 7s will cancel out for me. So w will be equal to, well, 35 divided by 7, which is 5. Now, how do I know if I'm right or wrong? This one's not too bad, right? The one-step equation here. But just to be sure, we can check with substitution. So when we do substitution, I'm going to rewrite the original equation. But instead of writing a w in there, I'm going to put parentheses, and then we're going to substitute, well, what do we think that value is going to be? So we think we solved it right, and it should be a 5. So now our goal is to make sure that both of these two sides are equivalent. Well, the 35, there's nothing else to do with, but just verifying one more time, 7 times 5, well, that does give us 35. So yes, indeed, we did get that problem right. It gave us what we call a true statement. True statement being that each value on either side of the equal sign is the exact same. On the contrary, an example of a false statement, something that would tell us that we did that problem wrong, would be something like 17 equals 35, which we know is not true. So we have standard form when it comes to equations. We have this method of substitution for finding out if we're right or wrong. So for a one-step equation, not really needed. But as we get into really complicated stuff as we move on, we're going to find this idea of substitution helps a ton. And then there's one more tricky problem with solving equations. And that's when we end up with not a positive variable, but we end up with a negative variable. So let's work with this example and kind of see what do we mean by that, and then how we can approach it. So I see a positive 2 here, so I want to do its opposite, which is subtract. My 2's cancel. Now notice there is a negative on that x still that comes with it, and that's going to be equal to 8 on this side. So now it comes down to, well, what do we do? We're not solving for negative x, it asks us to solve for positive x. So there's one of two things we can do. We can either multiply or we can divide by -1. So reminder, when we multiply by -1, it just changes the sign. Same thing if we divide. So in this case, for an example, I'm going to show it with division. Well, x divided by 1, that's still x. Negative divided by negative is now positive x. And then 8 divided by 1, that stays 8, but positive divided by negative, well, now that negative will move to the other side. So whenever we find ourselves with a negative still stuck on to the variable, we can either multiply or divide both sides by that -1 to get our final answer. Now, everything so far, for the most part, these have all been examples of one-step equations, which I know mathematicians aren't very original, right? They're called one-step equations because we can solve them all in one step. But now we're going to dive into two-step equations, and that'll be our focus for a while, and then we'll do more than that. So we'll have multi-step equations, and a lot more will come from the idea of solving equations. Now the big thing to remember, and this will be kind of hammered in over and over and over, whenever we're dealing with two-step equations, because we'll get the choice, should we add or subtract first, multiply or divide first, we get that choice. Anytime we can, we always want to either add or subtract a value away to the other side of the equation whenever possible. And as we turn the page, we're going to see an example why we want to do that and what happens if we don't. So as we come onto that third page, we got two examples on the top, and they're both the same equation, which is kind of weird, right? But we're going to solve this in two separate ways. So we're going to solve this doing first the ideal way, adding and subtracting first whenever possible, and then we're going to see what happens if we don't do that and we have to or choose to multiply and divide first. Now we will see there's going to be a special case of this down the road, but we'll worry about that when we get there. So first, adding, subtracting first. Well, whenever we solve equations, we're starting on the side that has the variable, because we want to move things away from the variable, we want to isolate it. And if I see addition, subtraction, so I'm seeing this -5 right here, so I'm going to add 5 to both sides. Well, now the -5 and that +5 cancel out. That's what we wanted. And we have 2x equals, well, 15 plus 5 is 20. Now that we've done that, we're then left with no other choice but to deal with this multiplication, and we do so with the opposite operation of division. So if I multiply by 2 with the x, divide by 2 to get rid of it, we get x is equal to, well, 20 divided by 2 is 10. Now every time, except for some rare occasions, we'll see this method of adding, subtracting first will have a very similar flow. Add, subtract over, multiply, divide, that last little step, handle a negative if we need to. Now let's see what happens if we don't do that. I'm going to multiply or divide first. Now, if I'm looking for multiplication division, I see that 2 times x right there. And someone else might think, well, it's not too bad, right? You could divide this by 2, so you divide the 15 by 2. We're missing out one thing. We have to also divide this -5 by 2. So whenever we multiply or divide, it has to be the everything on all sides. So every term is going to get divided or multiplied. Well, it's not too bad right here, right? The 2's cancel. But now we have x minus 5 halves. So now we're in the world of fractions. That's equal to 15 halves. Now we could use a calculator and get decimals, but if we continued with this, the next step would be to add or subtract this fraction. So I'm going to add the opposite of this fraction. Already, it's looking like more work than I saw over here. Negative and positive 5 halves cancel. Then I have 15 halves plus 5 halves. Can't add fractions without a common denominator. Thankfully, it is a common denominator of 2. So that makes this 15 plus 5, which is 20 divided by 2. And then that finally gives me the 10 I was expecting. So now it doesn't mean that we're wrong doing it this way. So once again, we see where math's giving us some options. But if we always add subtract first, that's going to save us from going this long road of fractions, which means more room for errors. And then there's this little question here. Which do you prefer above to do and why? That's kind of a personal choice, but I think on average, we're going to be preferring the less work. It's going to mean less room for errors, and we'll get through it that much faster. So moving on, before a couple examples, one final note to make on solving these more basic equations is that whenever we multiply or divide that two-step equation, or if we're dealing with more than that, we have to remember to multiply or divide on both sides of the equation. So as we did here, we divided that 2x and the 15, but it's not just on both sides, it's everything on both sides. So on both sides and everything on both sides. And that's the real kicker when it comes to multiplication and division. If we don't do addition and subtraction first, we have to remember this note right here. So one last example that we'll kind of do together of dealing with multiplying by 4 first, kind of showing what happens when we have to do that, or if I told you to do it. And then for the rest of these problems, you'll be given the choice, whatever method you prefer. So I'm asking you to multiply by 4 first, which means this x divided by 4 we have to multiply by 4. This 3 we have to multiply by 4, and this 5. So every separate term has to be multiplied by 4. Well, this 4 over 4 will cancel out for us, leaving 4 times 3, because the 4 had to go to the 3, and then also 5 times 4 on the other side. Now from here, 4 times 3 is 12, so we have x plus 12. 5 times 4 is 20. And that last step is the opposite of addition, which is subtraction. Positive negative 12s cancel, and we get x is equal to 20 minus 12, which is 8. Now the main focus again here is every separate term everywhere on both sides of the equations must either be multiplied or divided if we move that value. So that brings us to kind of the end of the notes for 5.1, kind of dealing with some basics of equations, and we have 4 examples down here. So I'm going to have you guys give it a pause and then work out these 4 examples, and when you come back, we'll do them together. Alrighty, so hopefully you gave these 4 a shot, and now we're going to work these out together. So I'm going to let you know that numbers 1 and 2 are one-step equations. We can solve them in one step. And 3 and 4 are two-step equations. So that means number 1 and number 2 should be a little quicker. For number 1, I see x minus 10. Again, I start where the variable is. And if I see that subtraction, I see that minus, I just want to do that opposite operation. So if I'm subtracting 10 from the x, I add 10 to get it out of there. Well, that leaves the x left over by itself, and then 14 and 10 is 24. Now again, if I was unsure, I could take this 24 and I could plug it back into the original. I could substitute it and go 24 minus 10. Yep, that's 14. Cool, I did it right. Now we got number 2. Number 2, I see multiplication on my variable. So it's 5 times the x. So I want to do some division if I see multiplication. And I want to move that 5 away from the x. Well, 5 divided by 5 is 1, or that just cancels out, leaving the x. And then 45 divided by 5 is 9. So for the first two, not too bad. There's no debate of what we need to do first. We just go right into that opposite operation. And that leads us to the last two. So for number 3, I see I can either multiply, see I have multiplication by 4, and I'm also subtracting 3. So I have a choice of what to do first. I'm going to go with that addition or subtraction first. So I'm going to take that minus 3 and I'm going to add it to both sides. Well, now the 3's will cancel out. That 4x is untouched, so it comes down. That 9 plus 3 gives me 12. And now after I've done that, no more debate. I see multiplication, so I use division. 4 divided by 4 again will cancel out, and 12 divided by 4 is 3. That brings us to the last problem, probably the toughest of the 4 problems. So I do see division, but I also see this positive 2 over here being added or subtracted, so I want to handle that positive 2 first. Although we're subtracting x over 3, the number itself is positive, which tells me I want to do the opposite, which is subtract 2. Again, the goal is 2 combined with whatever we do on both sides, we want those to cancel out. Well, 7 minus 2, we get 5. And now on the left-hand side, we want to remember we need to include and bring that negative, bring that subtraction with us. Well, now I see some division by 3, so what's my opposite operation? It's multiplication, so I want to multiply on both sides. The 3's over here are going to cancel out. 5 times 13 is 15. But again, I haven't dealt with this minus, this negative, so that has to come with us on that x. Now, again, we're solving for x, we're not solving for negative x, so there was a little trick to do to move that negative over, and that's to either multiply or divide by -1. But I'm going to give you a heads up of something you could have done here. So instead of multiplying by a positive 3, we could have included that negative with it, which means we would already have that positive x. But if you didn't, then reminder, you can either divide, which we did last time, or multiply by -1 on both sides. Well, the 1 times the x keeps it an x, which is what we want. Negative times negative is positive. And then we get a sign change on the right-hand side. And that sums up our 5.1 notes.